I think we're on part 7. Anyways, I hope you enjoyed the Virgin Galactico 2 launch. We still have 2 more launches today, dudes. There's Luna 25 with Soyuz, which we probably won't stream. Luna 25 is a lunar prospecting lander that's gonna head towards the South Pole, prospecting for water. And then there's a Starlink after that. So we're going all the way to the Starlink launch. We got another nice long stream for you today. So kick back, relax. Boom, boom. The captain has turned off the fasten seatbelt sign. You are now free to move about the stream. That being said, no one should care. Yeah, literally means it was in a book. It was in literature. Yeah, exactly. So Star Raker didn't get far enough, right? It was literally just literature. Literally. It never got off the drawing board, right? So that's using literally in the correct term. With that being said, I literally say literally all the time. I have that stupid Mad TV sketch from like 10 years ago to thank for that. Really annoying mindworm. Yeah. You know what I mean. I just want to see some Chinese launches for once. You're not going to find them here, Ripari. I won't do it. I won't stream that. And your second favorite phrase is "don't get me wrong." No, it's not. Don't get me wrong. I mean, it kind of is, but also think about it. How's it going? It's going. Exactly, yes. Something like that. S-Master. Sawyer is having problems with his Jeep. Very similar to yours. Get under the car and look at that crank position sensor. If the crank position sensor is out of whack or if it's moved, it's not going to get a good reading on when to tick the injectors. So get under there and take a look. You know where the crank position sensor is. Or it's aliens. This got real... That got a real laugh out loud out of you? Nice. Alright, I aim to please. I don't want to know what Blobby is, Tessa. What do? I know where it is. It's where the transmission connects to the engine on the driver's side. In front of the transfer case linkage. Like where the transmission connects. There's a crank position sensor. Remember the flywheel? The flywheel has that disc, or has that ring on it with the things interrupting. If the crank position sensor isn't getting a good read, the motor won't start. Because the computer doesn't know when to fire the injectors. Do you play KSP with mods? I have Kerbal Constructs, Roy, and a couple of graphics mods, and that's pretty much it. I still try to keep Kerbal with the base gameplay. But here. Oh yeah, I have KRPC as well. I have, I can code, I can use Python to automate stuff in KSP. Dude, I forgot we had that. We should go mess with it again. Here you go. This is KSP 1 Dead Scum, yep. They're winglets, not articulatable, not canards. Thank you very much. This isn't fly. There's not enough wings. Believe it or not. Yeah, not enough wings. Let me show you where we're really at. I'm not clicking on that, Tessa. I told you I'm ignoring the next 20 links from you. Don't think I forgot about that. This is where we're at. What do you think, dudes? Whose phone is ringing? Did my phone just go off? No, my phone's on silent. That wasn't me. Maybe it's probably just the ringing in the song. Did you make Mr. Cricket homeless? Actually, he stopped. Well, I don't know if he stopped. I think he left the building. Jimmy has left the building. I miss Jimmy. Dude, I didn't mind it when it was kind of chill in the background, but when it was really loud, then I could hear it through the headphones with music playing. That's when I started to be like, okay, please stop, Jimmy. There was a freaking cricket in my office last night. And at the beginning, like, or not beginning, like halfway through the stream, he landed on my arm. The freaking cricket. And I thought it was a grasshopper, so I didn't pay it any mind. I just kind of shoot him off, and then he started chirping. And that really pissed me off. How do you connect all those wing pieces together so it doesn't fall apart or flex weird? Well, Nils, the wings are made in strips. See that? They're made in strips. So, believe it or not, this more or less mimics the architecture of how a real wing is made. Real wings are made with strips of aluminum, or aluminium, or patamadme, or panda bear, or whatever. No, basically what you have to do, you need stringers to tie them together. Here, I'll give you a good example. Let's look at a space shuttle wing diagram. But a space shuttle wing is pretty good because there's pictures of it. See what I'm talking about? The wings, consider the wings these green pieces, right? The green pieces that kind of go out, right? But each piece right here, right, is connected via struts. Now, in Kerbal, the good thing is we have auto strut in Kerbal 1. So auto strut, actually, if you build it right, will end up making some of these struts for you. So you don't actually need to strut every single freaking thing together like this. I mean, look, there's 3 struts in between each stringer. See the 3 struts? And then the stringers connecting it all together? That's how real wings are made. I mean, wing architecture has gotten a little bit better than this since the 70s, but you get the idea. Yeah, there you go, Tylen. Interesting. Yeah, robot joke. Patamon, what's an aluminum falcon? What do you mean the rebels blew up the Death Star? Come on! I always use manual struts. Use the auto struts to your advantage. In this case, my auto struts are basically working this way. The auto struts work left to right. So that means all I need to do is the forward and back struts. Now, you could get away with doing... You could get away with strutting here to here, and then here to here, and then there to there. But what I'll end up doing is I'll tie in this structure here on a cross piece with the wings that will end up making up the bottom of this, okay? So, I can show you a more finished version with the K90. Give me 1 second. I have a plane that was kind of the prototype for this type of building method. And I've showed it on stream a lot over the past couple of days, but here you go. So, Niels, I have the same exact thing. See, the wings are made in strips, right? They're made going out like this. And you kind of have to make them that way, or else trying to position this is trying to sculpt out the wing is very difficult any other way. Like, manually placing each part is really difficult. But if you go down in here, look, I have the top left. This top left row is being attached to that bottom right row. And this top right row is being attached to the bottom left row. See the cross? There's another cross strut up here, right? These struts up here are making sure the wing doesn't fly apart. Ignore those for a second. The cross struts is what I'm trying to show you. See the crosses? Now, what I do on top of that is we have, obviously, on the Star Raker and on the K90, you have stuff in here. There's stuff inside of my wings. There's landing gear. I have additional intakes for the jet engines there that are... They're there because these Goliath engines make a little more thrust than a stock Goliath engine. We kind of did some stuff. And then I have additional fuel tanks. So the fuel tank ties the wing together top to bottom. There are struts in here somewhere, I think. I remember putting struts in there. Maybe I changed that. But basically use the stuff that you put inside of the wing to tie the wings together top to bottom. And then at the end of each strip, do an X-brace like that. And that, coupled with grandparent strut, will basically make this. I mean, Nils, I'm pretty sure you've seen me fly the K90 around. The wings don't bend. I mean, they bend just a little bit, but they're not floppy. They don't flex around. But see, basically with the space shuttle, right? With a space shuttle wing, that's the same exact thing. See the struts? My struts are just X-brace. The shuttle has two going like this and one going up. I have a cross strut like that in my design. But the thing is that you could emulate this if you really wanted to. But, Nils, if you emulated this shuttle wing design, you would have 50,000 freaking struts in your thing, and Kerbal would promptly say, no, please stop this immediately, right? So, use the auto struts to your advantage, right? Can you show the X struts again? Yeah, pilot. So, my wings are built. I have the top wing right there, and then the bottom wing is down here, right? The wings are built in strips. The tessellated wings, they're built out in strips, right? And at the end of the strip, right, I tie the wings together to the strip in front. So bottom left strip here, top right, top left, bottom right. I make an X brace. That ties this wing to that wing, and that wing to this wing. Now that's good, that's fine, but what this doesn't have here is that up and down strut right there. See that? See the up and down strut? We don't have that one. I find other ways to do it. Now, in this particular case, the reason why we don't have up and down struts is because my up and down struts are attached to that wing right there, that fat 455, the leading edge of the wing right here. See that? We're attached to the leading edge. And this wing is basically tying together all of this. That's what those other struts are. It's tying all of those together. You see? This strip right here is attached to that. This one is. This one's attached to that. This one's attached to it. Now, here's the thing. That wing isn't connected hierarchically. It's strutted to the strips, right? To the strips of wings. Because this wing is attached to that piece right there. It's attached to the main fuselage. And then I gizmoed it out. So this piece right here, that 455 wing, which is the base of my wing portion and the end of the blended part of the wing right here, in this design, that basically would have a huge cross member or a wing box that would connect right to here. Actually, I did connect it to the I made a wing box with this plane. Those wings are connected to the fuel tank, which is connected to the fuselage. See, I'm using the fuel tank as an integral structural piece here. Now that I'm looking at it. See when I select that fuel tank, it highlights the wing over there? The wing is attached to that. And the tessellated parts of the blended wing go around it. And that thing ties everything together. So the X-brace, with this being used as kind of an anchor part, formulates the wing box of the plane, and that's what holds everything together. And just like a wing box, if we lose the wing box, the whole plane will fall apart. I do study real aircraft architecture to get this stuff right. That in Kerbal Hierarchy, what Kerbal likes. But oftentimes what Kerbal likes in terms of structure is kind of similar to real life. The problem with KSP1 and KSP2 with structure is that there's no crumpling in KSP. You can't tell if a part is getting crushed. It's really hard to see it. Because it's not like Beam where you have soft body where the part will crumple. It'll just kind of sit there and it'll just jiggle around. It's really easy to load up parts with potential energy in KSP if you don't know what you're doing, if you don't know how to tie them in together. Like if you have a strut that's going too far, a float point error will basically try to bend the strut inadvertently, and you ever dock two things together like a space station? Dock a craft to a space station in KSP and the whole thing kind of shakes itself to pieces? Because you're loading up potential energy because float point error with struts. So, now, with that being said, there are other things. If you just have a high-mass vessel and your landing gear starts freaking out, you need more landing gear. But the game isn't going to tell you that. Your craft will just kind of skitch around on the surface, like sideways, when you don't have enough landing gear. So yeah, all that's kind of important to understand. Star Raker is going to have a K90 derived system like this. Bedtime. Good night, Ernok, and no one else. Night. So with Star Raker, the design's a little bit different because I don't have anything to really anchor to out here. So the wing strips, right, the stringers are going to be tied into the tanks. The tanks, once again, will be integral, and I'll use that as the wing box, which is... The cool thing is that that's not far off from... That is not far off from what Rockwell pretty much wanted to do. They wanted to use the tanks as integral structure to the wing. We load up this magical PDF here. That's what this is about. This is showing the integral tank structure to the wing. Smart. That is a little bit crazy because they have the tanks making up the structure of the wing, and then they have spray-on Sophie coating, the orange foam, and then they have a perforated honeycomb core on top of that with tiles on top of that, shuttle tiles. The other thing they were toying with is metal, a metallic thermal protection system with a silica backing blanket. I don't think that's not silica, cilia backing blankets, like basically fire blankets behind it. With an open medium here for conduction and convection, but that would have been harder to manufacture than this, to be honest with you. But also tiles. Tiles don't have the best track record on stuff that comes back down and flies around in the atmosphere. The reason why the space shuttle tiles were so temperamental is because they glued the tiles on to the skin of the vehicle, to the skin of the space shuttle, which was aluminum. The problem with using tiles that are silica-based, not cilia, silicate-based, right, is they're basically porous rocks. Almost sand, if you will. Sand absorbs water pretty well if you've ever been to the beach. Yeah, it absorbs water pretty well. So when the shuttle would come back down into a humid atmosphere like Florida, which I don't know if you guys have ever been down there, it's pretty humid. Pretty humid. The tiles would absorb all the condensation in the atmosphere. They would literally pull water vapor out of the atmosphere, and the tile would just hold water. Like a sponge almost, and that water would basically liquefy the glue and the tiles came off. That's why if you look at a picture of the space shuttle, towards the end of the program, or just any particular picture of one, let's see if we can find like a nice close-up picture of one. Yeah, here we go. So if you look at the tiles here, so you see the tiles that have dots? Those dots indicate a tile that has flown into space before. How many times? I don't know. I'm sure they had records of it. See the dots? The dots were tiles that have flown. That dot right there isn't some type of inspection or QA mark. That dot is them re-injecting the adhesive into the tile. That is gluing the tile back on without taking the tile off and gluing it back on. They re-injected the adhesive into the tile and it displaced the water out and re-glued the tile. That's what they ended up coming up with. Now, personally, I think switching to a unifibrous tile, a composite unifibrous tile, probably would have made that not a thing anymore. But who knows? So yeah, imagine you had to go through every tile. You have to see if it has water in it, and then if you figure out that it has water in it, you have to re-inject it, each one individually. There's 30,000 of them on the space shuttle, by the way. This strikes me as such a major design flaw. Pato, Dude, I understand that design flaws are a thing that are acknowledged by engineers. I don't like design flaws. I don't like that terminology because that implies that you don't... That implies that you don't understand what's going on, right? In this particular case, like, okay, Challenger is basically known as a design flaw. But the thing is they knew that the SRBs would do that. It's not a design flaw. That's not a design flaw. That's not the design's fault. It's doing something you don't want it to. And you know it's doing something you don't want it to, and you still fly it. That's not a design flaw. That's being stupid. I don't think design flaws, like... I understand with the aviation industry, there's absolutely things you didn't take into account, right? But design flaws usually come from insufficient testing, which that's a program management thing, you know? Like, I don't like that term. I acknowledge that it exists, but I don't like that term. The tiles, they knew the tiles would do this. They knew the tiles would do this in 1979. Because they flew Columbia to the Cape to get ready to integrate it to a stack and launch the thing. And they left it in the hangar overnight, and all the tiles fell off. Like, this is before the thing even flew. So they had to do a densification process with the shuttle that took 2 years. And even that densification process, the tiles still came off when the shuttle came back down and landed, right? Like... At that point, is it a design flaw, dude? I don't think it's a design flaw. I think you need to come up with a better tile. If you see me code, I never know what's going on. No, Pato, I'm not. I mean, like, and here's the other thing to take into account. Like, you sit there... Do you sit there and just, oh, well, we need to find a better way for the tiles to work? Or do you make a better tile? Like, and don't get me wrong, I had all the benefit of the knowledge learned during the shuttle program in hindsight, so it's easy for me to say, oh, just make a better tile. Like, I get it. But, tiles can come off during mission, during landing operations, right? And the solution there, oh, just glue it more. Now, don't get me wrong, that's a pretty good solution, and that did keep the shuttle operating on a relatively routine basis, relatively. Not what it was originally intended to do, but... Yeah. What were the meta tiles that Venture Star wanted to use? They're a titanium plated tile with... So it's a titanium plate with an aluminum box behind it. And inside of the aluminum box is cilia, a cilia thing. So it's a fibrous fire blanket, basically. Yeah, and they would have been mechanically adhered. Hellforce, they would have been bolted. So the titanium basically works as your heat plate, and the aluminum box with the cilia fibers behind it is your heat sink. It's not a bad idea. It's just titanium. Titanium thermal protection is... That's probably a little expensive. Yeah, Blue Flare, they had the unifibrous tiles by the end of the program. It sucks, huh? Why did they use glue instead? Well, Bob, that's one of those things that we have hindsight with. They glued the tiles on because, how else are you going to do it? I mean, I like to remind people that the space shuttle, for all of its crappy management decisions throughout the program, right? That the shuttle is a first attempt at a reusable launch vehicle. That's a first attempt. That's pretty frigging good for a first attempt. I still say that the shuttle doesn't really have many design flaws. I don't think it has design flaws. I think the design is just fine. It turns out when the design does something you don't want it to, and you just kind of say, "Man, it's fine," it'll end up doing something you really don't want it to. Like explode. Who knew, right? You might be familiar with Piecrete. It's ice and wood pulp. Yeah, they plan to make aircraft carriers out of them in World War II. I'm not entirely sure that would be a good thermal protection system, Pato, but I know what it is, yeah. I'm not calling it a flaw, I'm asking why. Was it the structure that they couldn't weld or bolt onto? Oh, okay, Bobs, I misunderstood. So they glued the tiles on because they didn't have a way to, okay, let me put it to you like this. The entire space shuttle is, so anything that goes through re-entry is a huge heat sink. There is a critical amount of fuel, not fuel, there's a critical amount of heat that any particular thing can take during re-entry. The heat shield doesn't absorb all the heat, it never will. It is still going to, the frame of the spacecraft, pod, space shuttle, whatever, is still going to conduct some heat. Why is it going to conduct some heat? It's attached to the heat shield. That has a lot to do with it. It's attached to it. So basically during re-entry, the fuselage of the shuttle does heat up a little bit, but it doesn't heat up enough to melt it. It's just enough to absorb a good amount of heat. The tiles are the heat sink there. They absorb most of the heat. And actually the space shuttle's nose cone deflects most of the plasma. It's designed to shoot plasma out and away from the space shuttle. And the tiles basically just work as a big heat sink at that point. They just can absorb crazy amounts of heat. But just because they can absorb all the heat doesn't mean that the entire space shuttle airframe, the fuselage, is not absorbing heat as well. What happens when you heat up aluminum? It expands. It just expands, it's a little wavy, right? So the entire space shuttle during re-entry actually kind of expanded a little bit. To be fair, so do the tiles. The tiles expand a little bit. Because but the rate that the fuselage is expanding at and the rate that the tiles are expanding at are different, right? They're different. So the fuselage is going to expand a little bit. The tiles are designed to expand and seal up against each other. When you heat up the tiles, they expand just at a good enough rate to basically butt up. If you notice a picture of the space shuttle, there's gaps in the tiles. There's like a little thin crease, right? Tiles need to heat up. They heat up a little bit, and when they do, they expand and they butt up against each other, forming a perfect seal, right? The space shuttle's airframe also does that. because it's not going to not absorb heat. It's still going to absorb heat. It turns out when you have a tile that's heated to like 1600 C attached to something, glued to something that's aluminum, it's going to heat up the glue and it's going to heat up the shuttle. So they all, because it's aluminum, because aluminum is not tile, they expand and contract at different rates. The glue is actually an ingenious solution to solve for this differential thermal expansion. Does that make sense? It's really smart when you think about it. The glue is there to basically allow the tiles to expand and contract at a different rate than the fuselage and keep everything together. It's pretty damn smart. Right? The glue actually isn't a bad idea, because if you bolt the tile, right? If you bolt it, it's going to try to expand, and it could pop the bolts right off. That's why you know, they're like, oh, why don't you just bolt the tiles to it? Then they won't pop off. Well, guess what? They'll basically just shear the bolts that it's bolted to. That it's bolted to, and then the tile will just pop off anyway. You've seen it with SpaceX, actually. Not even with heating. You see it with sound. Like when they static fired Starship, the tiles pop off. That's just with sound reverberations. The sound reverberation is enough to destroy the mechanical adhesion. That's why the glue was such a smart idea. Because the glue will expand and become rubbery, right, during re-entry, and it'll allow the tiles to expand and seal, and it'll allow the airframe to expand and contract. And they'll expand and contract at different rates, and it keeps everything nice and uniform. And then when everything cools down, the glue contracts again, the tiles contract, and the airframe contracts, and you get that gap between the panels again. It's really freaking smart, dude. That's really smart stuff. But yeah, that's why they went with the glue. Like, I know people are like, oh, why would they glue tiles? Why would they glue tiles? Well, you have to take into account the thermal expansion. Turns out when you heat things up, they expand. And in with re-entry heating, stuff heats up a lot. A lot. You know, the problem, once again, is that the tiles ended up being really good at absorbing water. Like, really good at absorbing water. Like, think a sponge on steroids. And the thing is that they'll absorb water and it won't ever come out. Water intrusion in the tiles is, yeah, it's hardcore. So, once again, the way they figured it out is to inject the glue into the tile and displace the water. Dr. Phil Metzger on Twitter has a couple of threads about that. He worked on thermal protection system during the shuttle, and he talked about re-injection. This is where I learned all this from. Yeah, that guy's really smart. Let me put it to you like that. He's way smarter than me. So usually when I find people that are way smarter than me, I shut up and listen. So I was listening. He had a thread on it on Twitter one time, and I was reading about the mechanical adhesion versus glue adhesion, you know, versus like tile re-injection and stuff. It's really, really interesting. The lunar flashlight mission. Shame. Hey RT, what's going on? Yeah, hopefully that helps. I'm wondering if we could have built a shuttle similar to the ones in Armageddon that used titanium as the heat shield instead of ceramic ones. Anything is possible, I guess. You gotta understand, Tigris, that those shuttles from Armageddon basically have whatever their propulsion systems were, it's basically Star Wars. The amount of Delta V you'd need to get out that far to an asteroid, yeah, those are the Millennium Falcon. The aluminum Falcon. What the heck is an aluminum Falcon? No, don't get me wrong. You can do a titanium thermal protection system. Sure, it can be done. But A titanium plate or titanium tile is not going to do it. Titanium is very, very heat resistant. It has a very, very high melting point. But the melting point of titanium is still below what you'd encounter during re-entry heat. So you need to conduct the heat away from the tile. You need the tile now, and then you need a heat sink behind the tile to be able to sink more heat, because the titanium will hit critical mass and it will melt. So if you have a titanium tile, you need some type of backing plate heat sink on it. Right? Think of it like a processor. A processor has the heat sink on it. That's how you would have to make a metallic thermal protection system. You've got to find a way to get the heat out of the tile, because the amount of heat that gets put into the tile during re-entry, it will melt the titanium plate. I mean, titanium's good. Don't get me wrong. It can absorb a lot of heat. Not enough for re-entry. Nope, not even close. Well, they did use Earth's gravity as a slingshot to get them out, to get them similar to how we do with probes. Yeah, they did do that, didn't they? Tigris, I would tell you to go look at any probe that uses Earth as a slingshot. Look at its trajectory and look at how long it takes to do a slingshot off of Earth. Usually to do a grav-assist off of Earth, you launch something into a solar orbit. It takes a year to come back around, and then it slingshots off of Earth. What they did in the movie is basically go up, turn around, go back, slingshot, and go up again. I'm telling you, the sci-fi drive. Like, if you have a drive that's good enough to go up and then turn around, come back, and grav assist off of the planet, why would you grav assist off the planet you launched from? The only way you're going to do that is if you can get to escape velocity on said planet. But since you launched from that planet, if you have enough delta V to get to escape velocity, there's no need for a slingshot. You don't need to do that. You're already going fast. You don't need to. You can't go faster again, right? I mean, you could use what's called the O-berth effect, sure, if you wanted to do that. But if you have enough to get to escape velocity, like what that shuttle did, if you have enough to do it in like 5 minutes, right? 5-10 minutes, you have a drive that's good enough to just get to the asteroid. You don't need to do grav assist when you have that much delta V. And that's what I'm telling you. It's a sci-fi drive. We don't have anything like that. There's nothing even close. But generally we use gravity slingshots in low energy transfers when you don't have the delta V to get somewhere. You use the grav well of another planet to increase kinetic energy. But in order to do that, you usually leave that planet's SOI and then have it come around and slingshot off of it. You can't just like go up to the moon, come back down, and slingshot off of Earth. I mean, you could, but if you're going to get out to the moon, right, and then come back and slingshot off of Earth, you could have just, you didn't even need to do a slingshot, you just left. The slingshot is inconsequential here in this regard. That's like having a car with a 100-gallon fuel tank and stopping every 5 miles for gas. That makes no sense. Why would you do that? You already have enough gas to go further than that. You know what I'm saying? EJ, they slingshot around the moon to get behind the asteroid in Armageddon. Alright. I'm done with this conversation. I'm not doing this, guys. Let me just tell you, if you think that Armageddon is reflective of any semblance of how modern spaceflight works, you need to reconsider what you're reading for spaceflight literature. let me, yeah, that's what I'm gonna say. It's a movie, guys. It's a movie. Please. Please. If that is your expectation for human spaceflight, you are going to be very disappointed. You know, you'll read about real human spaceflight and how it works, and you'll be like, I don't want to close my eyes. I don't want to fall asleep 'cause I miss you, babe, and I don't want to miss a thing. That's you when you figure out how inaccurate Armageddon is. Now do Deep Impact. I don't want to. Joe, don't make me do that. Please, can I work? Oh, boy. EJ, you're saying they went up and then slingshot around the Earth. They slingshot around the moon, not Earth. I agree with you, it's stupid, and it's not how it works in real life. But Dama, you understand that you saying, oh no, that's not what they did in the movie, is giving, that's doing the opposite of agreeing with me. You understand that you're not helping me in this regard. Does that make sense, dude? You saying me, what? That's not what they did in the movie. Well, that's not what they did in the movie. The whole premise of this conversation is that the movie isn't accurate. What they did in the movie doesn't matter. It's inaccurate. That is not agreeing with me. That's doing the opposite of that. Like, right? You understand this, right? Like, please don't make my job harder. It's harder to come up with analogies for rocket science that people understand. Don't make my job harder, man. You're killing me. You're killing me, Smalls. It's a Michael Bay movie. What do you got? What do you want? What are you expecting?
Chat, you're breaking my heart, Chat. I know it was you, Chat. You're breaking my heart. Fredo, I know it was you.
Anyway, let's go. So, I started working on the forward parts of the tessellated wing fuselage here. Yep. That's right, O-Force.
You're breaking my heart.
Anyway, I started working on it, guys, and I don't mind this, but where I left off last night was the wing leading edge. I had this idea of using curved flags with my color swatch flag pack here that Predominant made for me, that Graham made for me in chat. It's just basically a bunch of color swatches. I had the idea of using the flags for color swatch, using the flag with this color swatch as a wing leading edge. Where I'm kind of getting a little hung up is how I'm going to take the tessellated wing shape and blend it into that. Because I think that looks really nice. That's really good. That's a really good wing leading edge. And it's a physics-less part. Which means that Kerbал's not going to think I have a gigantic brick wall at the front of my wing. It means the wing will wing better. If that makes any sense. So, if we can figure out a way to blend the tessellated wing shape into that leading edge, we'll really be in business here. This will really look good. So I started working on this part last night, and it looks okay. Tessellation starts to really break down, like it starts to get really difficult to do and make it look good when you have crazy angles like this. Like, if you're looking for a nice fluid shape like that, it looks good. But, you know, you start to get seams and stuff when you start making... See what I mean? You start to get some pretty bad seams. I was kind of thinking maybe use the panels to... Maybe use panel tessellation to blend the shape, but... That works really well if you're trying to make a space shuttle, which basically gets brute forced up into space. Because this thing is a horizontal takeoff and landing SSTO, I have to take into account that it has to fly good. It has to fly like an airplane. And it has to be able to fly high enough and fast enough to get the shrubber engines to turn on, to get them to go into ramjet mode. So we really have to take into account aerodynamics here, or at least Kerbal aerodynamics. Does your Star Raker include the bay design? The bay is here. Yep. The bay is here. And yes, I have the hinge mechanism built in, and it'll look weird because my root part is on the cockpit. But yes, mine will do that, up in space and on the ground. I haven't designed that system yet, though. Because the reason why I haven't designed that system is because we're not getting very far if the plane can't take off. We're gonna take a payload up on its maiden voyage. No, I'd say just fly it. You just fly it empty on the way up. I mean, maybe, I don't know. Kerbals drive like your mom. Your mom drives like Kerbals. Wait, what? Yeah, that's the shape that I need, and that's where my wings are. It's not ideal. Sorry, come on, voice. Doing that Aerosmith impression, kind of. Yeah. All right, Nikita, see you, buddy. Take a look at this when you get a second. Rocket science simplified. You told ChatGPT to come up with analogies for technical rocket science such as delta V, specific impulse, and other advanced aerospace concepts that people can understand. Delta V. Imagine you have a full tank of gas in your car. The total distance you can drive, change in velocity, is analogous to the rocket's delta V. If you want to go further, you need more fuel and make more maneuvers. Specific impulse. Specific impulse can be likened to the fuel efficiency of a car in miles per gallon. ChatGPT plagiarized rocket propulsive elements. That's really funny to me, actually. That's pretty good. That's pretty funny, dude. Go look up the ISP, the specific impulse explanation definition, and rocket propulsive elements by George Sutton. Yep. ChatGPT plagiarized it. That's pretty funny, actually. That's almost word for word. That's pretty funny. Nice. Oops. Alright, discount. See you, buddy. Yeah, that's pretty good, ass. Yeah. I'm not sure what we're gonna do here. Because before on the K90, I used fairings as my wing leading edge, and I don't think that fairings are going to work for this very well. Can we use the panels for the leading edge? I mean, yeah, Shaw, we could do it. I mean, yeah, it can be done. Shaw, okay, I have an idiot question. Why don't we just use flags to blend the shape? Why would we use panels? I mean, clipping, yeah, but the flags, if we position them right, like if we have a flat flag right here, it's just going to clip into the wing. But if we're using flags to blend that wing leading edge, that was what I was asking yesterday. You were talking about using flags for this part, at least that's what I thought you were talking about. But yeah, I mean, I don't... Alright, we need to do some testing. Let's get these, not the Star Raker flight test, the Shrubber testing out. You can also use flags with alpha channels to get complicated shapes. I know. Yeah, I know that. Let's get out the Star Raker propulsion test article. And you know what I'm going to do? We're going to grab flags, right? We're going to grab flags. What did we want to use? 125s? So I'm just going to attach these here to this, and I'm just interested to see the aerodynamics involved here. What we'll do is have another one that's at a more of an angle that we would encounter during, like with Star Raker. I'm just interested to see how this kind of all plays out. I mean, that one, we're going to have a little bit of a seam there just because of how it is. But so this is our propulsion test article. It basically is, it's a vehicle that's testing out the air-breathing component engine. So the Star Raker air-breathing component, turbo, intercooled, ramjet. I can add more words to this and make it sound cooler engine that Star Raker would have had. And since we have a nice nose cone on it, we'll put the... put that up on there. That looks good. So I'll put the flags on here, and those ones will kind of be floating off the sides, but I want to use it to see how this thing reacts. So let's just see if we can get some aerodynamic data from this. And what I'll do, there's 2 of them here. I want to set one to panel mode. See how that one's thick now? I want to set that one to panel mode, and I just kind of want to see what type of aerodynamics we're going to get here. I'll set this one, I'll set that one to panel mode as well. Aren't they physicsless? Yes. Yeah, they are, Shaw. I want to have the solid panel ones just as a control, just so we can kind of see what's going on. So let's go take this for a spin, and we'll do some aero debugging here. How do you remember all these command options? I play the game too much, Ben. Can you use exhaust to test part drag? The aerodynamic simulation, Joe, is based off of relative motion of a craft. So spraying a rocket motor at something to see its aerodynamic properties, Kerbal doesn't understand that because it thinks the whole vehicle is standing still, right? That's why, I don't know if you were here the other day when I made that turbine thing when I was doing engine testing. I think that was the day that you subbed, if I'm remembering. I do appreciate it. Thanks, man. Excuse me. I was sitting here spraying a bunch of wings that were on a rotor to make it spin, and Kerbal didn't understand when the vehicle was standing still how to spin that thing. I was asking because that's why I was asking if it blew your mind. Yeah, did you see how it was spinning the wrong way? But then when I got the whole vehicle moving, it started doing what we thought it was going to do. Yeah, Kerbal doesn't understand it if the vehicle isn't moving. If the speed is 0, it won't understand relative airspeed there, because Kerbal at heart is not a fluid dynamic simulation. It's faking it, which is fine. I mean, if it was real fluid dynamics and working in real time. Yeah, that would have been pretty impressive. 1, how is this comparable in terms of aerodynamics to Star Raker? How do you make those big wing panels round? That is a flag with a wing shape, dude. Yeah. That's a flag, and the flag has a texture from the wing. That's not actually a wing. Thought I heard something. No, that's just the music. Alright. Yeah, okay, so the flags don't have any debug on them, but these ones absolutely do. Yeah, see how there's, if I select one of the flags that's in panel mode, see? Like that one right there, and we pin that window, you're getting an aero debug menu here, and that's going to show you how much drag it's making, its area coefficient of drag, Mach number, and this shows the skin drag and what types of drag it's making. And then obviously if you hit F12, you can see the visual. The ones that are in panel mode are making crazy drag, but the physicsless ones are not. Cool. Also, we use this to make sure that Star Raker's engines had enough kick. What do you think, Chad? You think that's enough kick, even with literally our speed brakes open? Dominator Add time. Yep, we're gonna die. I can't believe the vehicles stayed together there. It's not gonna stay together now. Nice. And we'll be right back after this commercial break. I'd be curious to see what the interaction of the flag is to this, because that was a lot of drag right there, guys. And total net drag usually doesn't change even with physics-less parts. So alright, I got another idea. So the physics-less parts seemingly work well, but once again, I gotta test one more thing. So what I'm going to do here is we're gonna, like I said, we're gonna do a little bit more testing. I just need to see the relationship. So what I will do is this. Get me a wing. Right, so we have two vertical stabilizers there. Right. That's fine. That shouldn't affect the vehicle too much. Now what I'm going to do is I'm going to take that flag again, right? And I'm going to put the leading edge, what we want for our prototype leading edge surface. I'm going to put it right here, okay? And once again, I have the wing. I had somebody make me a wing texture. See? Right there, so I can make the flags look like wings. It's good for blending shapes. If we do leading edges and we sculpt out the rest of the leading edge with flags, that's what I'll probably do to make the texture uniform. But in this group here, I have one with a physics-less part attached to it and one with nothing attached to it. So for this test, what I want to do is see, A, if the vehicle flies straight, then that would be a great leading edge candidate. And B, if the vehicle's flying straight, that means the imparted aerodynamics on these wings is going to be different. Because that's what physics-less parts do. A physics-less part isn't actually simulated. It's not susceptible to aerodynamics. It's not susceptible to heating. The part that it attaches to is, and it imparts the data onto that. So just because the flag isn't making drag doesn't mean it's not imparting it on a wing. So I have two of the exact same part, one with a physics-less part attached to it, one without. And we'll see if it changes. So with the wing, you have lift and drag right here. And with that wing, you have lift and drag indicated with the physics part on it. Let's see if these numbers are different. It is doing something, guys. Absolutely. Yeah, look at the difference. It's interesting because in this particular scenario, our lift gets exponentially. That's almost exponential. The drag is about the same though. Oh, nice. So it's a, does KSP take into account center of pressure moving at high Mach numbers? I'm not sure, Cyborg. It's because of the slight yaw, though. Tessa, our side slip is 0.3 degrees. You're telling me a 0.3 degree side slip is going to double the effective property of the wing? Here, I'll turn SAS on to keep us on a nice even heading. Now look at those numbers. Interesting. All right. I'm watching the rates. I think this is safe enough to say that the flag is imparting. All right. I think it's safe enough to say that the flag is imparting its physical properties on the wing. That's not anything we didn't know. I'm wondering the effect. Like, how much does it impart on that wing? Judging by the numbers that I saw before with the flags when they were in panel mode, I'm going to guess that the physics-less flag being attached to the wing might not make the same amount of drag as a panel flag attached to the wing. Like if I have a panel flag attached to the wing, the flag's going to create drag and the wing is going to create drag. But if I have a physics-less part attached to the wing, the panel is going to make no drag, but it's going to impart its mass onto the wing, and that's why we get differential numbers here. Right? That's why we get differential numbers. We could do another test with both of the wings on the top of the vehicle so it doesn't side slip and compound if we want to, but we are getting different numbers here. But the different numbers in force applied here is not equal to if I had a panel flag there. If I had a panel flag there, it'd be creating insane amounts of drag. Like way more than 0.04 kilonewtons at 217 meters a second at 5100. Way more. Mission Control, I'm going to put my NASA socks on right now. We got you, flight. What are the RNA values at the top section of the Aero UI? R and A. Okay, so that's 0.01 degrees a second radian, and that's 0.0 degrees a second angle. The degrees a second radian is your change rate. That's the one you got. That's the one you pay attention to. So I can tell by the rates on this vehicle that we have a 0.04 degrees a second radian change rate in our roll. So we have a compounding effect, meaning this means that the vehicle is always going to want to roll. That's or it is rolling, and we're slightly pitching downwards a little bit. We have a negative effect to a negative value and a positive effect to a negative value. So that means this number being positive is going to try to make that number positive. This number being negative is going to compound that. And basically, if I just let this thing go, it's just going to nose into the ground eventually. But another thing to understand here is that it's not dead stick right now. We're not dead stick. We have the SAS on. We have heading assist on. With heading assist on, if you look down here, your control input is compensating for the rates, meaning the vehicle's pretty much flying straight. And that's why the degrees a second angle number is 0. See what I mean? Does that make sense? This is what it wants to do. That's your control input, making sure that it's not doing anything. If I let go of the SAS, Joe, watch those numbers. They'll start changing. See? This basically tells you that if those numbers have value and those numbers have 0, that means the SAS or your control input is compensating for it. These are what's called vehicle rates. I'm sure you've heard that term get thrown around in real space flight before. Rates are super important. They're super important because this information tells you where the vehicle's going. Rates are important for guidance systems, for instance. If the vehicle can't figure out what its roll or what its YPR is and the rates regarding that, how can the computer compensate if it doesn't know that it's rolling to one side? That's really important to understand. That, and we don't have it, but potentiometers, G-forces. I mean, your forces are down here, so you could kind of extrapolate that data here. But if the vehicle doesn't know it's accelerating at 10.0 meters a second per second, right? How does it know it's going up? 10 meters a second is greater than 9.81 meters a second per second, which means your thrust-to-weight ratio is above 1, meaning you're going up. The computer won't know that unless it has a way to measure acceleration with a potentiometer or an inertial measuring unit or an accelerometer. You could use whatever. It depends on the guidance system. Hey, Mita. Ciao. It's radian and angular. That's what it is. Yeah, I said angle. It's angular. Excuse me. But see, check this out. Tessa, what do you make of this? So we're compensating. Angular is pretty much 0, so the vehicle isn't changing direction at all, right? It wants to go YPR here, but we're for the most part going straight on the stable trajectory at 182 meters a second. This is the paneled surface. That's the one with the flag on it. That one doesn't. The drag is the same, but the lift is different. And that is the same as what we saw up in the upper atmosphere going a lot faster. I'm wondering if the flags impart body lift and not drag when they're physicsless. When they're physicsless. Yes, someone, precisely. Yeah, the missile knows where it is isn't a meme. That's how guidance systems work. It just sounds funny when you say it in English. That can also be corrected by the GEA. Do me a favor and slap a lot of flags on the same part and get back to the same condition. Okay. Here, let me get you level flight with a nice round number so we can measure it. Let's go 240 meters a second at about 1900. That's good enough. Those are the values. Once again, we're seeing differential value here and similar drag. So I'm just going to take a screenshot of this so we have it, right? And we'll revert. Actually, I'll just bring it in for a landing. I don't think I've ever actually brought this thing back and landed it after its test flights. But we'll see here. You're down. A little rough, but it made it. We're back. Okay. Just need to end in the center of the runway. Yep. All right. So, Tessa, I'm going to do a couple of different changes here. Music. I'm going to do a couple of changes here. Actually, I don't know if I should do changes here. What I was thinking is taking this wing and attaching it to the top. Like that, and then having basically the exact same wing attached to the exact same part above it, like that, with nothing attached to it. But you wanted panels attached to this thing, so, or flags attached to it. I'll attach a bunch to the lower one, and we'll see what happens. So, all of these panels are attached, or all of the flags are attached to the lower wing, and not the upper wing. What are you testing here? I'm testing out using flags as a wing leading edge. Hey, Galatagian, thank you for the raid. All right, let's send it. We're just gonna send it. Just gonna send it. Just gonna send it. This reminds me of that dirty drone that was the only thing that beat my IV8 Kerbal Race Front. I think I won on style points alone. Yeah. Yeah, that thing was pretty cool, man. Yeah. Chad hated you for it, though. Alright, so that's the lower wing on the left. Upper wing on the right. This one has a bunch of flags attached to it. This one does not. Let's roll. Right, Dragon? Yeah, it's pretty cool. The nozzle occludes the engine, Zymus. It actually makes the engine more aerodynamic. I just made it look like a rocket engine. So it does do something, but it doesn't do what you think it does. But it also makes the engine glide through the air faster. We're doing some wing leading edge tests, Jim. We're trying to see if if you use flags as a wing leading edge for Star Raker, what it's going to do. Like, how does it screw with the parts that it attaches to? Tessa, that's a weird one, huh? Why were we getting that before then? Why was I getting such a big difference before? Now I'm... Alright, let's punch it. Hold on.
Going throttle up.
Yeah. If the vehicle had some natural rate moving to the left-right because it is asymmetric because there's a battery there and a probe core there, that explains that result. Because this is basically stating the opposite of this. Yeah, it's the same. That's why I wanted to put them right next to each other to eliminate that possibility that the vehicle is being asymmetric is screwing with our test results. On a scale from 1 to yes, how much yeet does this have? Enough for it to basically destroy itself in the atmosphere, Sneaky. The Shrubber engines are quite good. Cool thing about it, they're not overclocked. The Shrubber engines are not overclocked. It's just a regular Goliath with a regular whiplash. They're attached to each other with a pre-cooler, and it's cool because the whiplash is occluded. I don't think the Goliath is. I'm pretty sure the Goliath is not occluded, but the whiplash engine is occluded, so we get a lot of thrust, and that engine doesn't make a lot of drag because it's inside of a fairing that's shaped like a rocket nozzle, which is cool. The ramjet is occluded, which is pretty sweet. That's an awesome set, Nova. I mean, dude, this thing just punched way up there. Look at how high we are. 48 kilometers up. That's a long way. I wish we had the feather like Virgin Galactic right now. Actually, we could probably do it by hitting a deploy on this. It's not above the Kerbdowel line, the Kerman line. Poor little test craft. I think we'll be all right. This is fine. This is fine. Can we rerun the original test with our new experimental setup of the centered wings just to verify the error was, I think, in the asymmetry? Can we rerun the original test with our... I don't... Wait. Why would we... So you want to run one flag with the wings in that configuration. Why are we doing that? Ruski, Amerikanski. Спасибо. I won't go fast. Kinda like that, Nagwell. Yeah. Alright. That's the lower wing, flag wing. That's the upper one. Let's pause. So 593 at 29. I mean, this thing books. That's really fast for this altitude. 3.26, 342. Aren't the end ailerons causing unnecessary roll? My ailerons... I can lower the authority limiter if you want, but yeah, see, it goes out of whack because the plane is asymmetric, because the probe core is on the right-hand side. Parrot, I'm testing. I'm testing aerodynamics. English only, but please. So what I have here is flags. I have flags right here. There's flag parts that you can use in the game to put like letters and stuff on your vehicle. I want to try using the flags as a wing leading edge. So I want to use these for a wing lead. And right now I'm trying to see if attaching flags to pieces affects how they fly. They don't. They don't really seem to. They're physics-less. Is this faster than a Blackbird? In KSP, yeah, Suburbanite, yeah, absolutely. But you gotta remember, a lot of the parts in KSP are made out of, like, unobtainium. Going Mach 3 in Kerbal is not going Mach 3 in real life. That's very different. But yeah, it does go quick, and it kind of does look like a D21. I did that on purpose. I made it look like a Lockheed D21 on purpose. Absolutely. Alright, let's bring her in. I didn't see any differences. Just to confirm, the difference in the lift is actually the asymmetry. Well, considering this one has the same roll rates in degrees radian, I'd say we're conclusive. Yeah, the re-entry heating in KSP is very forgiving, even with it cranked to maximum difficulty. You're coming. You're down. Yeah, flags enable cloaking too, yeah. How the graphics mods that I have make the flags very weird. Like the alpha channel is still being rendered, so you could kind of see through stuff. Alright guys, so I'm pretty sure this kind of corroborates using flags as a wing leading edge. I think that's a good idea. Anybody that's been keeping track of the tests, do you think that's fair? I think this pretty much showed what we were looking for, huh? Yeah, Antares, you think so? Yeah, cuffs for sure. What were we testing? Using flags as a wing leading edge, Hellfish. Specifically, how does the flag impart its physics onto a part that it's attached to? I would like to do one more test actually now that you guys say something. Well, yeah. Now that I explained it, now I want to check something. I think it would be a good idea to test it with a non-wing part, just to see. So I'll get some panels right here, right? Both of the panels are attached to the jet engine. They're attached to the shrubber. They're not attached to each other. They just look like it. So what I'm going to do is take another flag piece, right? And we're going to make it bigger to the shape that we want, right? And the flag is attached to the lower panel. See? And then I have another panel with nothing attached to it. We could make telemetry recording software, Hellfish, using KRPC. It's doable. I don't see why we couldn't. Yeah, Cuffs. They forgot to uncheck transparency. It's rendering the alpha channel. Yeah. I don't know why you'd render the alpha channel if you're not using the alpha channel, but hey, whatever. Oh, I moved the gear around. That's right. You set the brake bias. Actually, no, that's not what you want. You want more on the front wheel. All right, cool. Here's the panel. The panel will show us more data. Or non-wing part will show us more data. So this is the control right here. That's the one with the flag attached to it. Obviously, the flag is physics-less. It doesn't have any aero data. So let's fire up the engines. R2, fire up the converters. Yeah, Hellfish. And we have our test bed, our propulsion test bed, to be able to basically do any type of testing with it. What about the flux capacitor? Well, we're not trying to time travel, Hank. If we were, I would have it installed. But we're already way past 88 miles an hour, you know? Alright. Turn on the SAS. It's not, it's negligible, guys. It's making no difference. That first test, we were getting differential lift from the asymmetry of the vehicle. I think that's pretty damn conclusive. I mean, and just to Mythbusters this thing, punch it. Okay, right. Oh, nice, Pythos. There you go. Hey, Rocket Guy. We're using our propulsion test bed here to test to see if using flags as a wing leading edge on Star Raker is going to have any aerodynamic effects on the vehicle. I think using the curved flags as a wing leading edge is a good idea, because it's a physics-less part. Kerbal will think there's a wing leading edge, or it'll think there's nothing there. But it won't think that there's a giant brick wall of parts there. Understand? Are you going to fix the invisible inside flag? Probably not on this plane, but... I'm just going to pause it here for a second. Take a look. Well, having nothing there as far as physics is concerned still cause some error issues. I don't know. I don't think so. What arrow issues would it cause someone? Just a random question now that you're using mods. What don't you use better cloud mod make the clouds look good in which make the clouds look good in KSP? I just haven't updated anything. I've seen the visual mods for KSP. They're fantastic, dude. It's all good, Ace. It's the shadow from the vehicle. Yeah, well, a little bit of a weird rendering thing there. Okay, not bad. Yeah, flags as a wing leading edge doesn't seem to cause any problems. Interesting. Nice. Lots of practice, Wolfie. Wouldn't having no leading edge cause a ton of drag from the air going in and getting stuck? It'd be like holding a cup outside of a car window with the open end facing forwards. Please let me know if I'm wrong. Someone, I'm confused. Are you talking about real life or are you talking about in Kerbal? Real life, yeah, you wouldn't want that, but that happens with fluid dynamic simulation, or well, real life. Kerbal doesn't have fluid dynamic simulation. Anything that it thinks is a wing, anything that we put as a wing leading edge, if it's not physicsless, Kerbal is going to think there's a brick wall of parts there, essentially. And air is going to go inside the wing regardless, because Kerbal also doesn't understand that that wing leading edge would be deflecting the air. KSP aero simulation doesn't work like that. The KSP aero simulation is basically saying what orientation is this part, where's the oncoming air coming from, and based off of that, this is how much drag and lift I should be making. So yeah, if you're making a wing, if you're making a tessellated wing like what we're doing, it's only Kerbal doesn't understand that these wings are together. And if you have a physicsless part as your leading edge, it still doesn't understand. I could put these wings like this, and it would still fly pretty much the same, barring any change of center or lift up to down because I move them apart from each other. Does that make sense, dude? Are you also testing the prototype engine? Yes, Anonymous, we already did some prototype engine testing the other day. But I've noticed that this thing does have some control problems, guys. The control problems from the prop test comes from our control point being offset to the longitudinal axis of the vehicle. That's why we're having problems. This is Schrabic, Star Raker air-breathing engine component. We call them shrubber engines because Schrabic kind of sounds like shrubbery. And we like shrubbery. So, what I want to do is take this, take that, put that back in like that, and then get rid of this for a moment, and then there you go. Essentially, it sees your projects as giant biplanes, for the most part, yeah. Okay, cool. Well, that's pretty neat, man. That's, yeah. I don't know why, but in my mind, KSP's aero engine simulated airflow around a part. Nah, it's just local. So if the wing is like this and air is coming this way, it just says I'm not going to generate a lot of lift and I'm going to generate a little bit of drag. But if the wing is like this, it says I'm going to generate a lot of lift and a little bit more drag. It's only localized to every single part. Yeah, that's how KSP Sim works. In fluid dynamics simulation, yes. Yeah. What you're saying is right. It would, you'd have to worry about where the air goes and intakes and whatnot. Hey, Violent, what's going on, buddy? I'm gonna put stators in here. Yeah. Awesome. Stators. Cool. In reality, if we were making the turbo ramjet right, we would need a... actually, this would work. This would work in a turbo ramjet design. You would want another nose cone back here. A la SR-71 style. This would work. This will work just fine. I feel like I've learned more in the last few days here than in a semester of college. Yeah. The info comes at you hot and heavy here, Joe. But yeah, thanks for watching, man. I'm glad you got something out of it, dude. For real. Put those flags on a motor. Glenn. What's up, Bree? How are you? What, Tessa? Are we gonna do a little bit of this, a little bit of that action right there, channeling the shockwave to the rim of the intake. We're going SR-71 style here. I'm good. How are you? I'm all right. Yeah, Ferrums is pretty cool, Aqualux, yeah. I don't know, maybe we mess with Ferrums one day. Does Ferrum work with the last version of KSP1? Basically, is it updated? Like your daily learning discovery channel. Yes. You could go full Leduc. That's what RT was saying. Leroy saying this reminds him of something called Leduc. I think I've heard of that, but Leduc. Plane. Planet Fitness. Yeah, no, that's what I typed. Thanks for that autocorrect. I really appreciate it. Yeah, RT, I this is not what I was thinking of. I was like, oh yeah, I know that plane. Nope, I was not thinking of that. When was the last update? Right before KSP2 came out. It's using a SNECMA 101. It does kind of look like that, doesn't it? Interesting. How do you eject from this thing? I don't think you... Wait, this isn't a drone? Wait, someone flies this? Is that the cockpit in the... What? Why would you want to do this? Why? What? 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 Wait! Wait, what? What is what? 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 But what? It does look like it, doesn't it? That's weird. Yeah, that's very strange. You know what the weird part about this, RT? When I was first making this, I was debating putting a canopy up at the front. Like, if you watch the stream where I built this, I put this up there first, and I was like, oh yeah, let's make it a man vehicle. Nah, never mind. That's really weird. It's at Le Bourget. Yeah. That's strange. Because, yeah, that... War. War never changes. Hug. Violet, I'm good. I had a conversation with a friend of mine saying, how did NASA in the 1960s, 70s get past the Van Allen belts when there's radiation and 5 to 10 million electron... 5... You had a conversation with a friend, Violet, saying... Well, he's asking, how did NASA, during the Apollo program, get past the Van Allen belts when there's radiation and 5 to 10 million electron volts? That would kill a man if passed through the Van Allen belt. Lead is too heavy, and it would fry the computers on the spaceship. Can you explain how they did it? Yeah, they went around it. They went around it. It's a belt, not a sphere. It just went around. Have you finished Star Raker? No, we were doing some propulsion and testing for aerodynamics, Cirrus. Violet, I'm also pretty sure your friend doesn't really fully understand how a magnetic field works. But yeah, you could just say they went around it, because that's what they did. There was actually a lot of tests. So, Violet, the thing is that they didn't actually go, like, completely around it. They purposely had tests that dipped through the Van Allen radiation belts, just to see. It's a ballsy move by the Apollo astronauts, because, yeah, going through there is a little bit dangerous. There's all different types of radiation trapped in Earth's magnetic field. That's what keeps us from frying, like chicken, down here on the surface. The magnetic field filters out a lot of it. They skirted the Van Allen radiation belts during the Apollo missions to understand how they worked. And with people, to be sure, but they went around it. They didn't go directly through the magnetic field. They went very much around it because they weren't sure. Funny enough, the capsule's internal wiring and electronics also help shield them during its electromagnetic interference and such. Yep. Last update is from a couple months ago. Good to know, Tessa. Okay. Yeah, Violent, they went around it. There were tons of experiments for them skirting with it. I wanted to say that they had a magnetometer as well. But... I think the magnetometer for during the Apollo mission. Yeah. Okay. Here, look. The magnetometer was an ALSEP experiment, Apollo Lunar Surface Experiments package. So the lunar surface magnetometer consisted of a triaxial fluxgate magnetometer and was part of a 3-station network, 12, 15, and 16, designed to measure the magnitude and temporal variations of the lunar surface magnetic field to yield information on the internal electromagnetic characteristics of the moon. Yeah, they didn't have a magnetometer. I was gonna say one of them had a magnetometer open when they flew through the Van Allen belts, but I can't seem to recall anything. This is cool coming to Intrepid. It's not coming to Intrepid, they're taking it away from Intrepid, T-Man. They took the Concorde away from Intrepid because it needs to be refurbished. They're going to refurbish it in the Brooklyn Navy Yard. Ring core sensor fluxgate magnetometers began replacing vector sensor magnetometers with Apollo 16 in 1972, where a 3-axis magnetometer was placed on the moon. Yeah. I thought it was the Apollo missions, but no, they dragged the magnetometer through the Van Allen belt on a different mission. Your friend watched the Y Files on YouTube. I don't know if you've heard of it. Judging by your friend's conclusions from that show, Violent, I don't want to hear of it. I'll be 100% real with you, man. Returning spring 2024. No, I plan on visiting in April. Oh, well, no. I've been inside of that plane, dude. Intrepid let Das and I go in it one time. It's pretty cool. Can you explain how a magnetometer works? I can tell you what it's used for. I don't know the operation. I don't know the principles of operation of it. It basically is a piece of sensing equipment that's designed to detect magnetic fields. And I understand triaxial magnetometers is using triangulation so they can locate magnetic fields, not just detect them. It can place them. You could figure out where it is because of triangulation between the magnetometers. It really depends on the type. Essentially, it monitors something that deflects due to the magnetic field flux and changes. Yeah. So, Rocket Guy, am I right in understanding that triaxial magnetometers are used to... the word I want to say is geolocate where the magnetic field is. It's not just detecting disruption. It's locating it due to the varying levels of disruption between the 3 magnetometers. Am I understanding that correctly? Depends on if you're talking the analog version or the solid state. Okay. Sure. Right. Right. Alright, let's go with one more test flight for this. I put the GLH badge on it. You guys know what that stands for? Go like heck. It's like an IMU, the 3-axis monitor magnetic field to get the entire magnetic field vector. Okay, gotcha. So what exactly are we testing? I was testing using panels as a wing leading edge, Jack. But I just want to fly this one more time. This is actually a pretty cool, pretty fun little plane to fly. But yeah, we were testing to make sure that we could use flags as wing leading edges on Star Raker. So like where the wings tessellate together, you can put the flag in front of it and make the shape. It's actually a pretty good idea. Flags are physics-less parts, so it basically won't treat it like, there's a brick wall on the front of the wing. Because I used fairings in the past to bring together tessellated wings, and the fairings cause insane amounts of drag. Yeah, see, as you can see, the Stravic engine is quite good. Yeah, it has pretty high TWR, to say the least. Our thrust is 331 kilonewtons, and our gravity force is 133 kilonewtons. We have over 2.0 TWR here. Interesting. The other thing that I wanted to see is there is some type of compounding pitch moment that this thing is doing, and I thought it was from the control point, but it's the arrow from the engine that's causing an interesting problem. You see that body lift vector right there? That's making this not happy. Now, don't get me wrong. On Star Raker, that's probably not going to make a difference. If I had to guess, that's probably coming from the fairing. Wait, what the hell is that nose cone in there? Wait, why is there a nose cone? Oh, that might be capping the fairing shape. Interesting. Okay. Huh. Alright. Alright, bring it around for another landing. Because we have a backwards facing fairing here, it's the game doesn't like fairings flying backwards. It really gets a little all antsy in its pantsy, you know what I mean? So yeah, I have a solution. I'll attach the forward nose cone where that aft nose cone is, and that the forward facing nose cone should make it understand it a little bit better. SpaceX to offer mid-inclination small sat ride-share launches. Cool. It's not a fan of them flying forward either. Yeah, you're not wrong. Didn't Artemis go through the Van Allen belt? It went around it. Actually, I'm not sure, Tomast. Pretty sure it went around. followed a similar trajectory, albeit a little bit lower energy transfer. I think we may have hit the nozzle. Oopsie doopsie. Okay, cool. I saw what I wanted to see. The stators look cool, though. How cool do the flag stators look? That's pretty rad. Just about to scratch your arms off. No, it isn't. Now stand aside, worthy adversary. Look, you stupid bastard, you got no arms left. Yes, I have. Look, it's just a flesh wound. Tin Town, ad time? Alright. And now, on to something completely different. Like an ad. I hate doing that. That doesn't feel right. It doesn't feel right, man. I don't feel right, Corbin. Corbin, I got a headache, my man. Alright, so we proved that flags will be a good leading edge for Star Raker. So, how do we go about making this? What do we attach the flags to? Right? Load. Load. Thank you. So right here, this represents where I want the wing leading edge to be. And those are the wings that we got. So, oh, there is one more thing we should probably test. Yeah, I did some work on the front here, Funky, yeah. It looks good, doesn't it? I really like how this part came out. But once again, these parts where we have to blend the wings and kind of trying to figure this out. Alright, move that block out of the way for now. Move that one out of the way. I need to see what we have. Curious to see how you fix the armpit. That's really what's killing me right now, Joe. I'm not really sure. You like it, someone? It looks good. It really does look nice, doesn't it? I mean, I think we might need to start with taking this piece right here. Let's just hit save. Take this sucker. And then just move this inboard of the wing leading edge. Just not by much, just a little bit. We're gonna have to screw with the tessellation a little bit. And now take this guy, and we gotta rotate that one this way a smidge. So right now I have the wing leading edge just attached to I-beams. We don't want to attach it to the I-beam on our final design, because then the I-beam is just going to make a ton of drag. Because it's an I-beam, it's not very aerodynamic. So We're gonna have to come up with some pretty weird hierarchical stuff to get this to work right. Thoughts on needing to replace the more vertical wing pieces near the cockpit for panels or flags that just might cause too much lateral force. I was thinking about that, Rocket. These parts are in flux because, once again, wing leading edge. I don't think if we chose to make them out of flags that it would be that big of a deal, because how big the V-stab is on this thing. But just because the V-stab is bigger doesn't mean that they could potentially have yaw, positive or negative yaw moment. So they could have side slip in this regard because the center of mass is biased towards the back. So leverage, them being further away, more moment. So even with something this big, yeah, you're right. Like, it could cause problems. But everything around the wing leading edge is in flux. I started sculpting out this shape, and then I was like, I was going to make it just go all the way around, right? And then I was like, I don't know about making that out of wings, especially the sides. You know, how many parts do you have left? We're probably like 35 to 40% complete here, Wombat. This part is, the top part of the vehicle is actually pretty damn good. This part right here is what it's going to look like when it's finished, minus the wing piece. But what I'm at now is A, getting the wings sculpted out, and B, getting my fuel tank designs right. Yeah, that's really going to be a little bit of a humdinger to get this one right. A little bit of a humdinger. I saw you scaling it like last week or 2 weeks ago, but you scaling it right now, it's like, wow, yeah. For like a week and a half progress, I think we've been going pretty quickly. It's not easy to make a plane this big in KSP. With this complicated of a design, it does. You really got to be careful. Yeah, it's tough. Why wasn't Methalox considered for Star Raker? Hydrolox was seen as more readily available, Nova. Methalox wasn't, dude. You don't understand. Methalox wasn't really something that anybody wanted until like the 80s, and then the Cold War basically put a fork in any Methalox technological developments. Methalox engines are something that's really come into like the meta for the industry in the past 5 to 10 years. Yeah, I would say 5 years. But anyway, Wombat, in terms of what do we need to do left, the control surfaces need to be custom made. That's going to get a little bit difficult. I have to do the underside wings, which there's not going to be nearly as much because the nacelle is there for the engines. And then the belly is going to be mostly fairing. So the wing tessellation will start here. It'll go up and over like that. But even doing that I still am going to need to figure out, I'm going to need to figure out the wing leading edges. Methane was pretty new. Methane is pretty new. Also, methane was harder to manufacture back then. Well, there you go, Rocket Guy. Nova, you'd say around 2015, Methalox was gaining traction since SpaceX started building and testing Raptor 1s at that point. If you knew when methane kind of came onto the scene, why would you ask if Star Raker, something that was designed 40 years ago, why methane wasn't considered? Also, methane smells. Actually, methane's odorless. It's sulfur that smells. So you're going to make Skylon as well? I've made Skylon before, Roy, because we have Sabre engines in the game, but yeah. Nah. This thing could move Skylon into space. Well, not with its wings, but Yeah, it just wasn't really the meta at the time, and yeah, that's probably due to it not being able to be manufactured, Nova. Piggyback ride Skylon. Let me put sulfur in with methane as the deterrent identifier for when working with methane. I'm not sure, officer, but that sounds right. Have you put in any time into figuring out the payload bay and how it'll actuate? I wanted to... Actually, I wanted to make this first, because if it doesn't open, who cares? But chat wanted me to do the wings. I was going to design that first. I have a basic thing. And I have an idea, I suppose, for how I want this to work. It's going to be it's going to be some pretty hardcore hybrid tech going on up here, for sure. Yeah, right now, I don't have an engine section made. Those engines aren't part of the actual fuselage, it's part of my jig. I don't have the engine section crafted out, and that's something that's going to need to be pretty strong because it's got 3 rocket engines pushing this entire mass of a plane around. So we got to be... I actually got to go back here and do it. It's not just making the wings. I see. Odd choice logically, but I voted for option 2 in mission mode, so I get
Discovery, go and throttle up.
Okay. How are we gonna blend this? I'm drawing a blank, guys. Like, we could use another panel, but I really think I need to look at, so. This is the one I was using a lot, a model. How are we gonna make that? I wonder. The leading edge is very ... caret. Wait, what? What do you mean? Like this? It's pointy. It's not, no, it's not pointy enough. It has to be more pointy. It is. You're not wrong. I mean, Core, what do you think? These are... Which ones are these? These are 1.25 panels. It might not be the worst idea to use the .625s because that's a smaller radius. Or not a smaller radius. You get... Yeah. We could make it more pointy that way. That's what I'm trying to tell you. Could be more pointy this way. Now, did this study material, did it have a bunny, now this study material, did it have a bunny, rabbit, and a duck? Oh. What? No? What's happening? I got some visual mods, Cloppy, and Kerbal constructs so I can build buildings outside. But yeah, for the most part, in terms of gameplay, like parts available, I have custom flag textures, but it's all the parts from Kerbal 1 and the 2 DLCs for Kerbal 1. For that and safety overall, it used to be that they didn't, and you'd never know if there was a gas leak unless you were poisoned by it or it exploded. They use the chemical. They do not just because we're super sensitive to it, and even the smallest leak will be smellable, but also because it attracts carnivores like vultures, making it easy to spot where your pipeline is leaking. Yeah, Breaking History and Breaking Ground was, yeah. It pushed Kerbal to the next level. What do you call these panels you put together to form a wing? The build method is wing tessellation quartz. That's what I call it. I'm actually almost thinking here that this needs to go up more, like up here. But it looks like the wing at the second armpit right there, which on this model seems, whoa. Hang on 1 second, guys. Do you actually have a manual from the 70s? It's a preliminary design PDF, Rafa, yeah. Showing basically how the thing could work. This is basically some preliminary analysis. But it does show that they did start considering building this thing. It never got to that point, but they were like, you know, we could make this. Like, it's doable, which is kind of nuts to me considering the complexity of the project. What about assembling 2 panels to form this? Panels really are not very aerodynamic, Quartz, and for supersonics and hypersonics, we'll pay the price making our leading edge out of panels. Understand? What prevented them from building it? Nobody wanted it in town. Think like A380, Boeing 2707. I mean, people wanted A380s, but they shut down A380 production pretty damn fast. The Boeing 2707, Boeing's answer to Concorde, Like halfway through development, Boeing basically went to all their customers and said, hey, look, if we make this supersonic transport to compete with
Discovery,
Concorde, you're going
go
to
and
buy
drop
it,
up.
right? And basically all of Boeing's customers said, no, we're not doing that. Make more 737s, please. And Boeing's like, all right, screw this. We're not making this. Hey, Miff. Miff, can you shoot me a DM, dude? I think I'm ready to do that thing we were talking about. Thanks for the 49, bud. I appreciate it. Is it a Supra? No, this isn't a Supra. Does this look like a Supra to you? Thus, the 747 became the greatest stopgap airliner ever. Yep. That thing you were talking about? Something like that. No, I screwed that up. I'm gonna have to make that again. It's alright. But yeah, when you get to the second wing armpit, the wing kind of levels out. And I think that's what's... I mean, first of all, it's probably better to get that right. Now we just gotta figure out how we're gonna make the shape. That doesn't make a bad shape. That's close. Hang on a second. Bad news, the guy who was voicing Dale Gribble died. Yeah, somebody was telling me that. That sucks. I don't know about using will strakes fit the profile at the leading edge. Strakes. The problem with the strakes is that they get skinnier over time, like this. So, like massaging this out, right, is kind of hard to do. I mean, we might be able to get away with it. It's possible. But now, I mean, That doesn't look too bad, dude. I might end up doing that just because I might end up doing that just because of part count. Because like flags, little tiny flags going all the way back, it's gonna be, I mean, they are physicsless parts, so interesting. I don't know. Because if we were going to do flat flags, this is how I would do it. Or if we were going to use flags, we'd have to get bigger pieces or bigger flags like this, right? And if one of them doesn't match the length like that, then we might need more, but let's see. With this, say we have 3 flags per segment like this, you know, provided like I could get this to line up, right? That'll look really nice. It'll look good. You can already tell it'll look nice. However, that's a lot of extra parts. But they are physicsless parts, so you never know. Did you know that koi fish travel in groups of 4? It's in case of danger. The A, B, and C koi are spared because they brought along a D koi. Strikes fit in the profile. What? I just told you that. Yeah, it's possible. There's no blend piece though, you know, like it's going to be difficult to blend these two together. I mean, we kind of did it right here, but that doesn't look exactly right. Like, what's the biggest flag here? And if we set that to, whoa. Okay, that's a little too big. What about you? Nope. Maybe the normal strake, not the big one. Hey, Ewok. Maybe these flags in a different orientation. Well, Joe, what I'm thinking at this point is, you know, I went to try to do the wings first, you know, like I'll finish the wings first and then try to blend the shape. But when I got out to the wing piece here, I was like, I don't really know how we're gonna, like, I don't know what we're gonna do. So, I wanna make the wing leading edge, so when I go to build the small wing, I know exactly where I need to blend and what I need to make it go to. Does that make sense? Yeah, I'm kind of like, I don't know. Nice, drummer. Yeah, I'm thinking, like, drawing a blank, which is not good. Well, Helfers, I'm gonna go up here and look at the orbiter for a second. I need to see something. Use 2 of those wing panels you just had and put them in a V shape along the border. That's not a bad idea, Cratch. How did I do it here? Yeah. So the leading edge, how did I do it? Is there any backing piece? Yeah, the I-beam is behind it. The I-beam's behind it, and the wing leading edges. The back side of the wing piece is the, that's the leading part of the strake, and then the panels are aligned to the strake. Oh, thanks, Roy. Yeah, shuttle is one of my favorites, man. I love this thing. I love my space shuttle. Yeah. This thing works and flies just like the real one, as best as it can. I got the robotic arm. All the lights are in the payload bay correctly. I have the antennas are in the right spots. It's yeah. This is a hardcore build. I cranked this thing out in a week. I couldn't believe it. Dude, I was on my game that week. And I did, you know what the funny thing is, dude? I had to sit here and I had to figure out the dang tessellation for the wing leading edge. I'm just trying to see what I did to see if I can replicate it. Want to see the cool part? This shuttle has no SAS in it. Nothing. There's no gyroscopic stabilization in this shuttle. It is aerodynamically stable, which was not easy to do. No SAS. No probe core torque. Wheel authority is at 0. There's nothing. It's a looker. Passing. It's a looker for sure. What a monster. We did such a good job with this, dude. It flies. I made it fly like the real one. So I had to figure out how the real one flies, and then I had to translate that into KSP, and on top of that, we had to make it look right. I'm trying to do the same thing for Star Raker right now. Problem is, the Star Raker is a little bit bigger than this one, you know? It's a little bit bigger. Can't wait for the KSP2 version. I'll start messing with 1 gen when they put re-entry heating in the game. Rocket science. Yeah, even the booster separation motors are placed. I found a PDF that said what the angles are, the thrust that they make, proportionally to the SRB. Yeah, it's all... The booster separation is the same. It's... Yeah, pretty hardcore. You're essentially creating Star Raker's flight characteristics. They did some dynamic analysis. Well, not dynamic analysis. They did some analysis on it in the PDF, dude, but yeah. Where's the PDF for booster separation? It's on NASA technical reports. Nova. NTRS. It's from like STS-35. It's the STS-35 booster separation analysis. Yeah. Super freaking useful. The space shuttle doesn't look like it's a complicated shape. It is an extremely complicated shape. It doesn't look like much, but yeah. So, yeah, for the wing leading edge right here, I used a combination of wings and panels to get it to look right. That's alright, Roy. It's wearing an exclamation, it's fine. Like, whoa, that's crazy. That's okay. That's cool. I don't mind that as much. I mean, try not to do it, but, you know, I try not to use curse words as every other adjective, you know. But it certainly illustrates the diversity of those words. What the frick, you frick? How did you frickin' frick? I always thought the shuttle ohms engines were angled. They are. Yeah, they are, dude. This one. No. Just hyped about that view. Think you're love? It's just beast. That's how I build, man. My builds take time. Sometimes months. But the payout is... It really drives the point home. Yeah, T-Man, the shuttle ohms thrusters are pointed up and out. They're pointed up, so they point through the shuttle center of mass, and they're pointing out like this, so they're pointing at the center of mass like this. There's a convergence point. The reason why they're pointed out like that is in case they lose one ohms thruster, the other ohms thruster is still pushing through the center of mass, and the shuttle can still get home. Passing, you find it? Cool. All right, let's try to massage these wings back into position. Look at all these wings. You want some of these wings? They don't got to know about it, chat. They could be our wings. Had to check your own research folder? Nice. No wings. Will ever be our... Ooh, that wasn't very nice. How about you, Sideburns? You want some of these wings? No wings for you. Nice. Come on, you wing. Get into the right position. There we go. Cool. Slow-mo footage from Yak. I know this is off topic, but Johnny Hardwick, the voice of Dale Gribble, passed away. Yeah. You know what Johnny Hardwick stands for? Fix it again, Tony. That sucks. That's awesome. Pocket sand. He's pocket sanding in heaven. I'd rather have a beer. Oh, that's so killer, man. Go. Ah, camera stabilization. Well, not stabilization. It's film stabilization, not camera. Oh, that's so good, man. What a track. That's... I am going to X this. How many G's do they get? I'm not 100% sure, Quartz. I would guess it's probably above 2. Probably not above 4. So somewhere between 2 and 4. Wasn't Jack just out in Boca? He literally drove he drove there overnight. Twix is the proper name. Ah, yes, I'm going to Twix this now. I can see the shape. I can see what I need to make. It's just when I go to make it, it never comes out what I see up there. Let's get rid of the rest of those, because it ain't gonna be any more than that. And then bring this one in. And then we need to change the angle of the dangle on that one. There. See, like, yeah, getting this blend up there is going to be tough. I'm not sure if we should switch to, like, panels. Then if we switch to panels, what's the point of putting flag surfaces there? Like, what's the point? Maybe putting the I-beam there and making the leading edge off that is not going to be that big of a deal. I'm not sure, dudes. I got an idea. Let's try something. If I can angle this in the right way, I might be able to get the wings close to where my leading edge needs to be. See how this is almost parallel to the I-beam? It's close. It's not exact, but it's close. If I can get it close, it'll be much easier to bridge the shape together with a fairing or with a strake or whatever. See, we can angle these pieces in such a way that the two spurring bearings are in direct line with the panometric fan. Every seventh conductor connected to a non-reversible Tremie pipe to the differential girdle spring on the up end of the Grammys. We have reached a very high level of development, and we are successfully operating in conjunction with Nofer trunnions. There we go. Ah, there's a seam there. How can we get rid of that seam? Jacobs, what's up, man? Remember to prevent that side fumbling. Yes. Now, see, this is the problem, right? In that particular area, I can get it to join up, and it looks right, but not over here. But maybe, if we did something like this. That's not really matching the I-beam now, is it? That's matching the I-beam. Oh boy. Yeah, that's definitely on the right track. I just don't know how I'm going to take this shape and do the same thing. That's not happening. I found your next project. Ah, neat. Cool. I've been staring at this for too long over the last couple of days, dudes. I think You guys want to switch to like Satisfactory or something? I've been staring at that for too long. I've just realized that over the past like 3 hours, I've moved like 1 or 2 pieces. I mean, we did do our aerodynamic testing, and that's cool, but yeah, I could tell you if I've been staring at it for too long because I'll just go silent and I'll be like, I don't know how to do this. You know, let's take a break from Star Raker for a couple of days here and pick it up with a fresh mind, probably on Monday. Or, I don't know, maybe tomorrow. It depends. Or Derail? You guys want to play Derail? Alright, you can play Derail. That's fine. Let's do it. Are you familiar with OpenTTD? Yes, absolutely. I saw a lot of Derail in there. Alright, let's roll. Let's choo-choo train it up.
Discovery, go at throttle up.
Well, 913 sub. Let's go, choo-choo. Yeah. Factory. I wanted to play Satisfactory, but there's a lot of people that want to play Derail. And I haven't played Derail in a little while. So Satisfactory also has rails in it. It's gonna make you baddier than you are anyway. Do what you fancy. It changes a good rest. Yeah, passing. We did the front, and I gotta. This is one of those things where I gotta kind of sit there when I'm late at night, when I have insomnia, and just sit there and think about it hard enough to freaking figure out what we want to do up there. Yeah. Start getting that tier 4 stuff making in Satisfactory. Rev, both are good. Derail requires a lot more situational awareness. I'm heating up the bunker C. You guys aren't making this easy. The factory must grow. You're not making this easy. All right. Okay. We will flip a frickin' coin, okay? We'll flip a coin. So, heads is Satisfactory, tails is Derail Valley, best 2 out of 3. Okie dokie. Heads is Derail, tails is Satisfactory. 2 out of 3. Okay, that's 1 for Satisfactory. Okay. Damn. Alright. Maybe after the Starlink launch tonight, we'll maybe plug into some Derail. I'll tell you what, though. Whatever game won, so Satisfactory won, we play Derail tomorrow, okay? Does that sound good? The coin don't lie. Indeed, it does not. We'll train it up tomorrow. Chief, hold on the bunker C. We're going to fire it up tomorrow. You said KSP tomorrow. I said maybe KSP tomorrow. I mean, I don't want to sit there and just stare at the thing. That's not really good streaming content, man. If I can't think of a process to even try and solve the problem, I've been staring at it for too long. The coin knows what you truly want. Yeah, you're probably... dude... I mean, I always... Whenever I flip a coin to decide something, Rev, I always do 2 out of 3. Just because. I know that doesn't really make a difference. Your odds don't change, right? Like... Let me change up the title here. Actually, I gotta Put synergy back over there like that. Switching the burners off. Just for now. Just for now. Keep them in standby. Hello? Let's just call this Skyscraper Factory Build.